Hi, this is Ms. Zhu, and we're going to be going over the practice chapter 4 test homework given tonight. And we're going to start with the first question. Which of the following numbers is divisible by 3? The rule for dividing a number by 3 would be to add the digits. This is also in your foldable notes, so if you need to refer to that, please do. You add the digits, and you see if the sum of that would be divisible by 3. So here my answer, if I add the 8 plus the 1 plus the 9, then together that makes 18, and I know that 18 can divide by 3, so that's why my answer is C. Number 2, my answer for number 2 would be A. Same rule as number 1 for the rule of divisibility for 3, but instead of adding the digits, after I add the digits, I want to see if the sum can divide by the number 9 instead of 3. So if I add up all those, 1 plus 7 plus 8 plus 2, that's 8 plus 10, which is 18, and 18 divides by 9. None of the answers do that for us. Number 3, the answer is going to be D. I do want to caution you, as you are watching this video, there are some questions I'm not going to explain very much in detail. So I would probably work on the worksheet first, finish it, and then view the answers so that you don't see the answers before doing the questions. But if there's a specific question you need help on, then go ahead and fast forward to that section of the video. For number 4, when you're listing the factors, there's 2 methods you can use. One is the rainbow method. I want you to use one of them, whether it's the rainbow or the factor tower. Okay, so if I use the rainbow, then I would start with the number 1. Just like in the tower, I might start with the number 1. It pairs up with the number 54, so 54 would be my rainbow here. And again, the rainbow method is just to check that 1 times 54 makes 54, and those 2 would be factors, numbers that can divide evenly without a remainder into the number 54. Comma, I'm going to include the number 2. I know it's an even number, so 2 divided by 57 would give me 27. Okay, those 2 pair up. And then I'm going to try 3. 3 would work because 5 plus 4 equals to 9, so I know it's divisible by 3. It happens to divide into 3 18 times, so 3 is going to go with the 18. This is just to make sure I don't leave numbers out. I'm going to try 4. 4 doesn't work. 5 doesn't work. So then I'm going to try 6. I'll go down here, 6. 6 goes with 9, so 6 and 9. And then if I check 7 doesn't work, 8 doesn't work. And if I go back to 9, then I know that I've just started over because I already had a 9, even in the tower. So here would be my final answer for number 4. Okay, and I make sure that my rainbows all line up so I don't have any missing numbers in my list of all the factors, all. Number 5, I'm making a factor tree. A factor tree would be me making little branches, and these 2 numbers can both can divide by 10, so I'm going to do 10. It goes into it 65 times. Then I'm going to do a factor here, which is 2 and 5. Over here, 65, I know can divide by 5, and that's going to go into 13 times. So these would be my prime factors at the end of the factor tree, and my final answer would be 2 times 5 to the 2nd power times 13, and there's my final answer. Okay, and it doesn't matter the order too much, but proper math, we always write smallest number first, and then to the largest number in that order. Number 6, this problem means 5 times 5 times 5 times 5. And if I pair up the 5s, that's 25 times 25, giving me the answer D. And go ahead and make sure that you multiply those 2 numbers together, showing your work in each question. Number 7, 3 to the 4th power means 3 times 3 times 3 times 3. Pair those up, 9 times 9 gives us answer D, 81. Number 8, when I read this question, I'm writing 3 to the 6th power. That just means I'm going to write it with an exponent. So we do understand that 6th power means that the exponent will be 6. So that's why my answer is C, because this means 3 to the 6th power, and that's how it reads. Answer definitely not B or D or A. Okay. Number 9, We need to follow PEMDAS in this question, making sure that we understand that exponents is after parentheses but before multiplying. So I would do that part first here, the exponent. So 3 times 3 times 3 is going to give us 9 times 3, which is 27. So I'm going to rewrite the whole question. 3 is going to add with 27, multiply with a 3, and then divide with a 9. Following PEMDAS, I would then do the multiplying that's right here. 27 times 3 is going to give me 81. Okay, so I'm going to do 3 plus 81, divide with 9. So then I'm going to do the dividing, because after and multiplying is dividing. So 81 divided by 9 is 9, so I'm going to write it over here. 3 add with the 9, which then gives me the answer 12. So number 9 is 12. Okay, number 10, I'm going to follow PEMDAS again. So I'm going to do the exponents here first. So 20 divided by 5 minus, that gives me 4. Then I'm going to do dividing or subtract first in PEMDAS. That would be divide. So I'm going to divide. That would be 4 minus 4, and then my final answer would be 0. Okay, that's number 10. Number 11, I'm looking for how many of these numbers listed here would be considered composite, so I'm going to go ahead and check. Remember that composite means numbers that have more than two factors. The opposite of a prime number, because prime numbers would only be the factor 1 in itself. Now 18 I know has also the factor 2 and 9. 4 also has 2 and 2, so that's a composite. 15 has like 3 and 5, so that's composite. 21 has 3 and 7, which is composite. 34 also is composite. 22 is composite. 55 is composite. They're all composites, so how many are there? 1, 2, 3, 4, 5, 6, 7 of them. So my answer is D. 7 numbers here are composite. I'm going to work number 12. What is the greatest common factor for 30 and 75? I'm going to do hockey sticks, find out what divides by both, which is going to be the number 5. Okay, and I'm going to get 6 and 15. Then I'm going to do another hockey stick. 6 and 15 can both divide by 3, giving me 2 down here and 5 over here. I cannot do another hockey stick, so the greatest common factor would be to multiply the side numbers. So 5 times 3 makes 15. That's my greatest common factor. Now if I did the hockey stick and I wanted to find least common multiple, then I would multiply the 5 with the 3 and the 2 and the 5, making like an L shape down here. Side and bottom was LCM, but the question is only asking for a greatest common factor, so I only multiply 5 and 3. Now when I need to do a greatest common factor for variables, first of all I'll do it for the numbers. So the greatest common factor of 4 and 8 would be 4, and 1 and 2. So 4 is going to be part of my answer. And all I'm going to do is I'm going to find common. So that's going to be my keyword. I'm looking for what letters they both have. Now for this one I'm going to expand it out. So here I'm going to expand that out to give me A times B times C, C, C. So over here I expanded it out. Then I'm going to expand next this part out from here, which is A and then B, B. So when I circle what is common, I circle a A, I circle a B, and that all seems like they only have those in common. So my final answer would be the 4 that they both had, and then an A and a B. So that would be my greatest common factor for ones with variables. Okay. Number 14, to simplify, I would divide both numbers by 4, and I would get 10 and 12. But I'm going to divide both of them again by 2 to give me 5 and 6. So that's how I would simplify a fraction. Number 15, the answer is 2 over 3. Not going to explain that one. Number 16, which one is in the simplest form except for... Now, basically I'm looking for if I can divide any more numbers. So if I look at A, 51, well 5 plus 1 is 6, so I know I could divide by 3. Let me check if 153, 1 plus 5 plus 3 is going to give me 9, so that also divides by 3, which means that A is not even in its simplest form. So if I wanted to go back and double check the other answers, I could do that because it seems like all of them are simplified except for A. Number 17, I'm going to write that as a power. 3 times 3 times 3 I know is the same as B here. Number 18, going back to the top, all of them are true except. Now, if I'm looking at these and it confuses me, what I need to do is expand it out. And that's always going to help me figure out which one might be incorrect. So if I look at A, if I were to expand that out, B to the fourth is B times B times B times B. And another B to the fourth, which would give me another times B times B times B times B. It says it's equal to B to the 16, but there's only 8B, so well, clearly that is not correct. But if I look at all of my other choices, it seemed like I added 7 and the 2 and got 9. Okay, added the 5 and the 1 and got 6. Added 3 and the 6 and got 9. So I would have noticed at least some type of pattern that was happening in all of the answer choices, except for A. That's not really what happened with the 4 and the 4. So that can also help me in a multiple choice question eliminate some choices where there's similarities in answers, and clearly you can't have similar answers in all your choices. So A's got to be it. Okay. Number 19. I'm going to apply in our notes what is rule number 5 here to, this is a power to a power, okay, and so I'm going to multiply here and here, so I get z to the 12th times z to the 30, okay. Now it seems like I'm multiplying powers, and when I multiply powers, yeah, I could write all this out. I could write z, 12 of them. Okay, it's really long. I'm not even going to write all. And then 30 z's over here. But instead of doing that, I'm just going to apply the rule in our notes, which was rule 3. And that is to add 12 and the 30 together, which makes z to the 42nd power. So that would be my answer for 19. Okay, so I needed to apply 2 rules in 19 to get my final answer. In number 20, I'm just going to apply rule number 5. It's a power to a power, so I'm just multiplying the 6 and the 8 to get 48 for my exponent. Number 20, I can expand it out by writing 2 to 12 of them, okay, and then write 4 of them at the denominator. So I'm going to cross out the ones I don't need, and if I count how many are left here, there are 8 of them, which means that there's 2 to the 8th power, okay? And the simplified answer would be 4 times 4 times 4 times 4, which would actually give me 256 as the most simplified answer, okay? Number 22 through 27 here. 22, I'm going to expand it out. So all these questions, if I can expand it out, I would do that to help simplify. So number 22, negative 2 to the 4th power means negative 2 times negative 2 times negative 2 times negative 2. And in my denominator, I have negative 2 times negative 2 2 times. I can simplify by crossing out 2 negative 2's that are there. And if I figure out the answer to negative 2 times negative 2, that's the same as 4. Okay. I could have also applied rule number 4 from our foldable notes, which would have been to subtract the exponents from one another, but keep the bases, so the base would have been negative 2. And if I subtract 4 minus 2, that would give me the number 2 for my exponent. So negative 2 to the 2nd power is again the same thing as negative 2 times negative 2, still giving our final answer positive 4. So again, when in doubt, you can expand it out. Or if you remember rule number 4, then to apply rule number 4 to the question. Number 23, because of the negative exponents, my answer is not simplified. I want to write it in a positive exponent. So I'm going to do that for both of them. So I'm going to do the reciprocal for both. For this one, it's going to be 1 over y, and then I'm going to take it to the 2nd power, and then I'm going to do it for the z, 1 over z to the 5th power. So really my final answer, I could just write 1 over y squared z to the 5th. Okay? Number 24, I'm going to expand it out. That's the method I'm going to take here, which would be x times x times x times x. I've got 7 of them. Okay, my denominator, I have 5 x's. Okay, Then I'm going to simplify. So because of the division sign, I know that these x's equal 1 that match up